Okay, so I'm going to start a session here as soon as this thing fires up. Okay, so I'll have a true-false question. Oh, I need to make the text larger. Let's just get this. True, false. So A will be true and B will be false on your clicker devices. Okay? And so we will say true, false. Placebos are used in both observational studies and experiments. Okay, so this will be your first clicker question. So this will be clicker question 1. Okay, and so with your clicker question, this is the base. I'm just using the default frequency, which is AA. Okay, when you're connected, it should say like stats 10 on your screen or something like that. Does it say anything like that or no? No, it doesn't say that. Okay, so maybe I don't have it configured correctly, but it should say here. Let me just. I think course settings. Oh, look at this. Okay, welcome message. Okay, I'll say stats 10, and I'll click save. Does it? I don't know. Does it look? Okay, is it showing up on your things now? Maybe. Yes. Okay, so you need a frequency AA. Okay, and then and that's what all this says. Okay. Press A, then press A. Okay, base frequency code is AA. All right, you don't. If it's already set to AA, don't click anything. Okay. So I'm gonna click close here, and then you should be able to start clicking the whatever your buttons to answer. Okay. So people are answering. Okay, so we'll stop the clock at I don't know, 45 seconds here. Okay. Something. There's like little bugs landing on me while I'm up here. I don't know what's going on. Okay. Everybody get their clicks in? I'm gonna count down 3, 2, 1, and yeah, you're having a problem? Huh? I don't. Yeah, I think you hold down your power and then you just hit AA twice. Okay. Hold down the power until the little set frequency thing flashes. You're good. Okay. Everybody else good? Okay, so we'll hit stop here. Let's take a look. Okay, and yes, that is the answer. Answer choice B. Placebos are used in both observational studies and experiments. That is false. Okay, placebos are used only in experiments. Okay, and the only reason why we use placebos is because we've assigned treatments and we don't want the patients or the participants to know which treatment they've received, and so a placebo is used to keep them in the dark about which treatment they have received. Okay, so we are good there. And this is lecture 4, week 3, Monday. Okay, great. You guys have a quiz tomorrow. Covers chapters 1 through 3. It'll be taken in discussion section. I've emailed out the quiz to the TAs. They are responsible for printing out the quizzes and bringing it to class. If your TA didn't do that, let me know, okay? Because then they'll get in trouble. So, because you guys, well, I don't know what to do. So, all right. So we will continue on our lecture in chapter 4. Okay, so this is chapter 4 continued. And we are covering relationships between two numeric variables. All right, and so we left off and we said when describing a relationship between two numeric variables, there are three things that we want to mention. Okay, and that is the direction or trend, and that will be either positive, negative, or neither. Then we have the strength of a relationship, which goes anywhere from weak to strong. And then number 3 is the shape or form, which will either be linear or nonlinear. Okay, and I'm hoping this all sounds familiar to you guys from our Friday lecture. Well, let me just mention another thing about the clickers. So the way the points work, and I will upload your clicker points tonight, so please check online to make sure you're getting points appropriately. The way it works is that for each session there is one participation point that you get just for clicking a button at some point during the lecture, okay? And then you get 1 point per question that you answer correctly. So if I ask 4 questions during the lecture, there will be a total of 5 participation points available, okay? One for the, and so if you answer all 4 questions incorrectly, you would get 1 point, okay? And if you answer all 4 questions correctly, you'd get 5 points, okay? So your scores can be anywhere from 1 to 5. You get 1 just from participating, and then 1 more for each question you answer correctly, okay? And so from lecture to lecture, I might ask anywhere from, I would say, 2 to 4, 2 to 5 questions, and so the amount of points that you get will depend on from lecture to lecture. Again, if you miss class or something goes wrong with your clicker, I can't really do anything. I don't have everything's controlled by the internal software here, so I don't have fine-tuned control to say like, oh, give this student back points here, something like that. Okay, so if your clicker breaks or something just doesn't work one day, you're going to miss points for that day, okay? But in the grand scheme of things, it's going to have a minimal impact on your grade, okay? I mean, if you miss all of the points, then that's 5%. But I imagine, just missing 1 session or something like that, it's going to have a very small impact in the total grade, okay? And then I generally ask harder questions for clickers, things like that, because I use them as kind of a point, starting point to discuss some of the concepts I want to cover. I think sometimes the clicker questions reappear on tests and stuff like that, so it's good to kind of browse through your notes and things like that. But I do generally put some of the tougher questions as clicker ones. Okay. Okay, so when describing a relationship, we mentioned these things: direction, trend, and strength, and shape and form. Okay. And so we have a sample statistic or a numeric summary that tells us the direction and the strength of a linear relationship. Okay, and that's called the correlation coefficient. Okay, and the symbol is R. Okay, R for like relationship. Okay, and the correlation, so correlation coefficient, we often just call it correlation. Correlation exists even for nonlinear relationships, except the interpretation will not make sense. Does exist for nonlinear relationships, but the interpretation will not make sense. Or I shouldn't say will not make sense. Well, the interpretation will not be correct. Okay, because correlation is just you throw the numbers into a formula and it spits it out. Okay, but the value that it spits out only makes sense and only has interpretations when the relationship is linear. Okay, and how can we tell if a relationship is linear? What do we do? To see if a relationship is linear, okay, so well, I'll write this down then. Okay, to see if a relationship is linear, okay, we must graph it. We must create a scatter plot. And look with our eyes. I mean, that sounds it sounds silly, but our eyes, our brains are very good at deciding, does this kind of look like a straight line or not? Okay, and I'd say our eyes are better than well, I mean, we have sophisticated algorithms that are pretty good these days, but as far as, you know, mathematical methods that are appropriate for an introductory statistics class, the eyes will be much better, okay? So you just look at it. If it looks like a straight line, sure, you say it's a linear relationship. Okay, so let's talk about R. So the value R can take on any value between 1 and positive 1, okay? The sign of R is the, so this is, you know, for linear relationships, okay? So for linear relationships, okay, the sign of R is the sign of the direction, okay, or is the direction of the relationship. Are you guys hearing that? It sounds like someone's knocking on this board behind me, and I keep looking over my shoulder expecting someone to come out and grab me. All right. The sign of R is the direction of the relationship. So, you know, that means, you know, if R is positive, the direction of the relationship is positive, okay? Okay, and likewise, if R is negative, then the direction of the relationship is negative. I don't think I have to write that sentence down as well, right? You guys, you can figure that out. Okay, and then the if R is close to 0, the strength is weak. And if R is far from 0, so that means close to 1 or close to -1, because that's as far as it can get from 0, the strength is strong. R itself does not tell you if the relationship is linear or not. Okay? Only if R is equal to 1 or -1. Okay? But even when R is 0.99, it doesn't tell you that it's linear. Okay? So R in general will not tell you if the relationship is linear or not. Okay? Unless R is exactly 1 or -1. That's the only time you can say it's linear. But even at R equal to 0.99, you can't say, oh, that's a linear relationship. Okay, so R does not tell us if the form is linear or not. Okay, only if R equals 1 or -1. Okay, but at any other value, even R at 0.99, can't say that. Okay, I'm going to flip to the next slide, if that's all right. Okay, so let's just kind of draw some stuff here. Okay, so here, so here I've got a straight line. Okay, so the dots in a straight line. Okay, is there scatter here? No, no scatter, no scatter. And I will tell you that R in this case is +1. Okay, R is +1 here. Okay, or just 1. Okay, so here I've got clicker question 2. And your answer choices are R is equal to 1, B is R is positive, but less than 1. Okay, C will be R is close to 0. Okay, and D will be R is negative. Okay, so here is the picture. Let's see. Okay, so this I will say not flat. It's not flat. There's no scatter. Okay. Okay, so go ahead and make a choice here. Okay, so I guess you can talk. You can talk to your neighbors if you're unsure. Huh? We'll give you guys a... okay. So not flat, no scatter. I'll say dots in a straight line. Okay, so I'll say 10 more seconds. Okay, so when this hits 1:15, I'm going to hit stop. Okay, so you got 5 seconds to get your clicks in. Okay, and then stop here. Okay, let's see how you guys answered. Oh, all right. This is like a nation divided here. Okay, the answer choice is answer choice is A. Okay, R is equal to 1. All right. So again, what does R measure? R measures the direction and the strength. Okay, so the direction is positive. Okay, it's not a flat line. Okay, I tried to say that it's positive by saying it's not a flat line. And yes, you're right. The slope is not as steep, but did I say anywhere that R measures the slope? No. Okay, R does not measure the slope. It just measures the strength of a relationship. Okay, and so in both cases, the strength is kind of determined by how much scatter there is, right? And so here I said no scatter, and R is +1, and over here we also have no scatter, so R is also +1. Okay, so that brings up a good point here, that R is not influenced by a slope. Yes?
Can you give us an example where R would be positive but less than that?
Yes, that is the exact same question someone had last class also. So yes, I will get there, okay? But let me just kind of use this to say, just kind of reiterate just some of the things about R, okay? So I'm going to flip to the next slide. And so R is, R does not measure slope. Okay, it just measures direction and strength. Okay, so when we talk about R not measuring slope, R is not affected if you add a constant or multiply by a constant. Add a constant or multiply by a constant the values in x or y. Okay, so you can add constants to x, you can add constants to y, or multiply x by a constant or multiply y by a constant. It's not going to affect R. Okay, so effectively that's what slope does, right? Slope just really just multiplies all of the values by a constant and it's not affected by that. Okay, so R is not affected. Okay, and then switching x or y, switching x with y, switching x and y will not affect R either. Okay, so when is R positive but not equal to 1? Okay, so here just a positive relationship but a little bit of scatter. Okay, we got a little bit of scatter here. Here I'm going to just say R is like 0.85 or something like that. Okay, I'm just kind of making up this value here, but this is R is positive. Direction is positive. Direction in R is positive, but some scatter. Some scatter, so R is not +1. Okay, but still pretty strong. Okay, some scatter, pretty strong relationship. Okay, and then if you increase the amount of scatter, okay, but you overall still have a positive relationship, maybe R is positive 0.5 or something. Okay. So direction is still positive. Okay, but you know, more scatter. Is that okay? And then, so can I flip to the next slide here? Okay, and then so if we have relationships that are negative, okay, so this would be, what would the R value here be? -1, okay. And then here, R equal to -0.7. I'm just making up a number here, okay? Maybe -0.75. Who knows, okay? So just to say negative relationship but some scatter, right? Negative relationship. Okay, some but not too much scatter. And your textbook has some good pictures to illustrate this. We have a question.
What if the line is horizontal?
Yeah, what if the line is horizontal? That's a good question. Okay, so let's see. What if the line is horizontal? So if, let's say I have this. What would R be?
0, 0.
R would be 0, okay? Because R is neither positive nor negative, okay? So R is 0 in this case.
There's scatter.
What if there's scatter? Okay, so neither positive nor negative. Okay. Okay, and if there's some scatter, but overall, what is R here? Also 0. Okay, and now, I mean, there's a possibility that, you know, because R is calculated by these formulas, there's a possibility, you know, maybe R is equal to 0.01 or R is equal to -0.02 or something where it's like very, very close to 0, but not exactly 0, just because the dots happen to line up just ever so slightly different from 0. That's also possible because, you know, we're just throwing dots into a formula, and it spits out a value for us, okay? And again, all of these interpretations only make sense if, after you create a scatter plot, you say, hey, the relationship looks linear, okay? Because if it's not linear, because if I were to graph this, okay, I would probably get R is equal to 0.98 or something like this, okay? But we shouldn't, R is not appropriate to be used here because it's not a linear relationship, okay? R is not an appropriate measure. Appropriate measure to be used. Okay, is that all right? So let's try another clicker question. There's a little bit of controversy in the last class, so I'll try to make it as unambiguous as possible. Okay, so your answer choices will be, you know, R is very close to 1. B will be R is, you know, between, we'll say 0.6 and 0.85 or something, and then C will be R is close to 0. D will be R is between -0.6 and -0.85, and E, R is very close to -1, Okay, and then so your x will be average temperature for the day. Okay, and then y will be total dollars sales of sweaters at a department store for the day. Okay. All right, so go ahead and clickety click. So the temperature is measured at the location of the department store, okay? So, you know, temps are measured at the... Yeah, well, I can't answer exactly how much scatter there is, so you have to think, you know, how... So I'll give you until 1 minute and 30 seconds here, okay? Okay, 10 seconds, 10 seconds. Okay, and 3, 2, 1, click, click, click. Okay. All right, let's see what you guys put in. Okay, and I would say that is the correct answer. Answer choice D. All right. So, you know, if we think about temperature, all right, so you think of a day where the temperature is high, are you going to be selling a lot of sweaters that day? Probably not, okay? But there might be like a clearance or something, and so I'm expecting some scatter, okay? Not a ton, but overall we should still see a negative trend, where on days where low temperature you're going to have higher sales figures, and then in between you'd get in between values and stuff like that. I'm not expecting something very close to -1 because that would indicate something where there's just very minimal scatter. And I don't think that's the case with sales figures. Sales figures just fluctuate anyway, so on a day-to-day basis. But I think we would see some kind of negative trend there. Okay, so that's what I've got here. Good? Okay, so now we're going to start switching over to this topic of linear regression. Okay? Linear regression is an analysis technique for relationships between two numeric variables, okay? And with linear regression, we try to model the straight line relationship between x and y, okay? And so when we're talking about linear regression, it only makes sense if you have a straight line relationship, okay? So again, only works if there is a straight line relationship. And that requires us to create a scatter plot and to look with our eyes, okay? To see, all right, I guess create a scatter plot and look. I guess it's redundant to say look with your eyes, but so you just have to see, and if it looks like there's a linear relationship, then we can go on with linear regression. Okay, so think back to algebra. What is the equation that, what is the form of the equation for a straight line? Yeah, okay, so from algebra, a straight line is in the form y equals mx plus b, okay? And m would be our slope and b is our intercept, right? And we called the slope-intercept form. And there's actually, I think in algebra you learn other forms too. You have like point-slope form, and then you have, what was the other one? Coordinate something, right? Standard? I don't know. Okay. Something. All right. So in statistics, we change the letters, okay? We say y hat is equal to a plus bx. All right? Okay, y hat, a here is our intercept, and b is our slope. Okay, y hat stands for, is our prediction for y at a certain value of x. For a certain value of x. Okay. Okay, and so basically what we're saying is that if you give me a certain value of x, my prediction for y hat is a plus b times x. Is that okay? All right, and so what we do is, you know, we look at our data and we're going to try to fit a line that summarizes the relationship between x and y. Okay? So let's say this is my data. I've got x and I've got y. Okay? And so x will be 1, 2, 3, 4, and y will be 2, 6, 4, and 8. Okay? So I'm going to graph this. And I'm going to go 1, 2, 3, 4. So I got 1, 2, 2, 6, 3, 4, and 4, 8. Something like that. Okay? So I want to, you know, this is my data, and I want to create a relationship between x and y. All right? So I want to say, you know, can I summarize this relationship with a straight line? Okay? So, you know, can we you know, summarize or model the relationship with a straight line? Okay, and just looking at it, like, just we've created the scatter plot, we're looking at it. Yeah, sure, straight line. Yeah, I guess that could work. Okay, and then so the question is, what is the best? What line should I use? Okay, and so I'm going to draw like two candidate lines here. Okay, and one will look like this. Okay, so you know, there's one line. Okay, and then here's another line that looks like this. Okay, and then you know, what do you think? The green line's better? The red line's better? Okay, assume these are straight on my picture here. Okay, I did the best I could. All right, you know, I mean, clearly, you know, if I were to draw blue, blue does not look like a good line that summarizes the relationship between our data points, right? So we can say blue does not do a good job of summarizing the relationship between x and y in our data. Okay. But green and red, they both seem reasonable, right? Green and red both seem reasonable. Green and red seem reasonable. Okay, so which line is better? All right. Okay. So how are we going to measure which line is better? Well, I'll tell you. Okay, but I want to make sure I can flip to the next slide before I do. And we're not going to finish this topic here, okay? Not today. Okay, so what we're going to do is we're going to measure, we're going to see the amount of error in our lines, okay? So we will look at the amount of error we have in our prediction lines. Okay, and so the error will be defined as the difference between our prediction, the difference between an actual value and what we predicted. Okay. You know, the actual value of y for a given x and what we predicted. Okay, so for example, let's say, you know, I have x is 1, 2, 3, 4. And the actual values of y were 2, 6, 4, and 8. And I'm plotting this. And I got this, 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 and this, right? Okay, and then so let's say we look at the green line. And the green line goes like this, okay? So for the green line, our equation will be y hat is equal to 2x, okay? So under the green line, what am I predicting? I'm predicting, can you guys see this okay? So I would predict 2, 4, 6, and 8, right? So if okay, so I'm going to have error. Error will be the difference between the actual value and what I predicted. Okay, so for this dot, it's right, you know, the actual value is 2, of what I predicted is 2, so I have 0 error. Okay, this dot here, okay, I predicted, according to our equation, I predicted a value of 4, but the actual value was 6. Okay, so I have a difference of 2. Okay. And then for this one, I also have a difference of 2. We're going to say it's -2, okay? But you know, effectively the same, all right? And then this last one, it's right on the dot, so we have 0 here. All right? Is this okay? So what we're doing is we've created, you know, kind of the line of, we're saying is this green line where y hat is equal to 2x. Is this a good line? And then we're going to say, okay, well, let's look at the actual values, right? And what we predicted. And then we're going to see how much error we have. Okay? Okay. Oh, we're going to run out of time. Okay, so, the best fit line, I'll just write this now, okay? So the best fitting line will be the least squares line. In statistics, we like to use squares for some reason, okay? The least squares line, okay? And so we will try to minimize the squares of our residuals. Okay, so we will try to minimize the squares of our errors, I should say. Try to minimize the squares of our errors. Okay, I think we are out of time for today, so we will end here. We'll pick this topic up on Wednesday. Good luck on your quiz tomorrow. It covers chapters 1 through 3, okay? So we'll see you guys on Wednesday.